To Let's Talk Chemistry with Pastor Dan, we're looking at covalent bonding. Covalent bonding, unlike ionic, which is by electron transfer caused by electronegativity, ionization energy, covalent bonding is bonding due to sharing electron pair due to electronegativity. Now that's sort of like electron affinity, but we're pulling on the electrons, and what atoms prefer to pull? That would be a nonmetal. So covalent bond is always a nonmetal to nonmetal bond. All right, so we're going to look at something called Lewis structures opposed to Lewis dot. Lewis dot is ionic, so therefore there are rules for it. First rule is determine the number of valence electrons. Remember, we count the columns to get the valence electrons we need to work with. And then find the center. It's the one that's the least number. Usually it's 1, okay? Put atoms or other atoms around it, so fill them around. We're going to form a bond with an electron pair. That means 2 electrons. Complete the octet. What was that? Complete the octet of the outer elements, and then extra electrons go on the central atom. If electrons have an atom left, we're going to do an octet, double, or even triple bond. And then lastly, if there's not enough equal bonding, we're going to use something called resonance, and that's used occasionally. All right, so let's look at the first structure. We're going to do something called NH3, that's ammonia. All right, so nitrogen has 5. Count the columns. It's in that nitrogen group. Hydrogen, it's an alkali group. First column, we call that 1 valence electron, but there are 3 of them. So 1 times 3 is 3, 5 plus 3, that's 8 electrons. Now, which is the center? There's 1 nitrogen, 3 hydrogen, so nitrogen is my center. Put my hydrogens around. I need 2 electrons to bond up, so that's 6 electrons gone. Now, hydrogen, I have 2 electrons. Hydrogen is happy with 2, so it's totally fine. So it's this one and that one. They're all good. So I have 2 extras. Remember, it says extras go in the center. So there we go. And that nitrogen, 1, 2, 3, 4, 5, 6, 7, 8, it's an octet. It's happy. So that's also good to go. All right, now let's do something called boron trifluoride. Now this is going to be a little bit different. Again, we count the number of valence electrons. I have 3 for boron. Chlorine is 7 times 3. That's 28 electrons, 24 electrons to work with, which is the center, boron, fluorine. It's only 1 boron. Fluorines go around. Now, I could either use dots like I did before, or I could use a line. Now, when I use a line, a single line, it means 2 electrons. So 1, 2, 3, 4, 5, 6. Subtract 6 away. That leaves me with 18. Now, I need to fill the octet. I didn't have to do the last one because hydrogen only needs 2, but fluorine needs 8. So therefore, we're going to put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That's all the electrons I have. I'm all out. I don't have enough, so am I going to do something weird? No, I'm not. Why? Well, here's the reason. Boron's a moron. What does that mean? Well, boron is happy with 6 electrons, so therefore it's the only one that does that. We're good to go. Let's do another structure here. This time we're going to do carbon dioxide. This one isn't a moron. We're going to do something different. So we have 4 electrons for carbon, 6 for oxygen times 2, that's 12. So I have 16 electrons to work with. Carbon's my center, oxygen on both sides. I'm going to use a line. A line needs 2. So 1, 2, 3, 4, subtract that away, 12 electrons left over. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm all out of electrons, and both my oxygens are happy, but my carbon's not happy. I only have 1, 2, 3, 4. I'm not enough. So remember, go back to our list of rules. If we don't have enough, what do? We have to double bond. What does that mean? Take one of the pairs from the oxygen and move it to the bond. I now still have 8 on the oxygen. 1, 2, 3, 4, 5, 6, 7, 8. How about that carbon? Is it happy now? Not yet. It only has 6. So what should we do? Double bond the other side. So take the electron from the other side, move it to one. It can move from anywhere. We don't have to use it from the ends. And now carbon is happy. All right, let's try this one. This one's a little bit easier. Carbon tetrafluoride. Carbon has 4. Oxygen 7 times 4. That's 28. 32 electrons. Carbon's going to be in my center. Chlorines go around. A line needs 2. 2 times 4. That's 8 electrons. 24 electrons. 6 on each chlorine to make 8 with a 2. So 6, 12, 18, 24. Everybody's happy. Carbon's happy. Good to go. All right. Now, let's do these 2. These next 2 are not going to make very happy, but this is where life takes us. So sulfur dioxide. Sulfur has 6. Oxygen has 6 times 2. That's 12. 12 and 6 is 18 electrons. Sulfur is my center. Oxygen on each side, bond up with 2 electrons. 1, 2, 3, 4, subtract them away. 14 electrons. I need the outer electrons first to fill up. So I need 6 on each. 6 times 2 is 12. Subtract that away. 2 extras. Where do extras go? Extras are always on the center. Is my oxygen happy? Yes. Oxygen happy? Yes. Sulfur happy? Not so much. We don't have enough. What do? We double bond. So we take one of the pairs, move it to the bond. Could I have done the opposite side? Yes. And because of that, I have to show it. So I draw the same structure, double bond on the other side. And in reality, the way we understand it, there's a half a bond that exists between both of them. So I have to show that it's in flux, and it can't show just put one dot. So therefore, I use an arrow between this. This is what we call resonance. Okay, let's try another one. Sulfur trioxide. You're not like this one either. Same process. I have 6 for sulfur. 6 times 3, that's 18. So I have 24 electrons to work with. Sulfur is my center. And I bond up my oxygen. That's 6. Subtract 6 away. That leaves with 18. 6 times 3, that's 18. Look at it, you're going to realize, oh no, sulfur doesn't have enough, so I'm going to have to double bond. So I can take a bond there. I could have done the other one, so I have to show it. And then I could have shown it on top, so I have to show it. Arrow between. There we go. All right. Now, that's also a resonance structure. Now, a couple more things we have to do. First one is called polyatomics. These are covalent molecules with a charge. So let's take a look here. We have 5 for phosphorus, counting the columns. 6 times 4, that's 24. When we add those together, we get 29. But we have this little -3 here. What does that -3 mean? That -3 means I have 3 extra electrons. So I actually have 32 electrons. Phosphorus is my center. Oxygens go around. 2 times 4, that's 8 electrons. Subtract that away, 24. 6 times 4, that's 24. They're all there. So, but remember, this is charged. This is Lewis, so we still have to have the brackets. And -3 or 3 negative, either is correct. That's a polyatomic. We can also go the other way. Let's do the only polyatomic, well, one of a few polyatomics are positive, we call cations. So we have 5 and 4, but it's -1 because of the positive charge. So we subtract 1 electron away. So we have 8 electrons around. Nitrogen and hydrogen's around. 2 electrons to bond up. 2 times 4, that's 8 electrons. But remember, this is charge. So you need brackets and positive. Remember, hydrogen is happy with 2 electrons. We're good to go. All right, and the last thing we'll look at before we finish up here is something called superoctet molecules. With more than 8, we can do 10. We can even do 12 around the center atom. All right, so let's do selenium tetrafluoride. Selenium has 6. Fluorine has 7 times 4. That's 28 electrons. 6 and 24, 34 electrons. Selenium is my center. Fluorines go around. There are 4 bonds are needed, 2 electrons per bond. That's 8 electrons, 26. Put 4 times 6 to finish them up. That's only 24. That means I have 2 extras. 2 extras go on the center. I have 10 electrons on that structure. Let's try the next one. Krypton difluoride. Now remember we talked about the polyatomic, the noble gases. Noble gases were called inert. They don't want to react. It's shown to react here. What does that mean? That means it's so electronegative. Fluorine is so electronegative, it makes a noble gas react with it. And this does work. So we have 8 valence electrons for krypton, 7 times 4, 7 times 2, that's 14 electrons. So I have 22 electrons, which is my center. Only have 1 krypton, so krypton goes down, fluorine on each side, 2 electrons per bond. So 1, 2, 3, 4, subtract 4 away, 18 electrons. Now start on the fluorines. I need 6 times 2. That's 12 electrons, 6 after. They have to go in pairs, in groups of 2. So 1, 2, 3, 4, 5, 6. I have 10 electrons in the center. That is a superoctet molecule. All right, so I've got 4 structures I want you to do. I want you to work through and identify these, do them, and then pause the video, and we'll go over the answers together. Okay, here we go. So boron, remember boron has 24 electrons. Boron's a boron. It's happy with 6, so we're good to go. PCl3, phosphorus trichloride, 26 electrons, 2 extras on the center. Everyone's happy. We have 5 plus 18 plus 1 more because of the negative. It's 24 electrons. Nitrogen doesn't have enough, so we have to double bond 1, but I could have done the other 2. It's a third of a bond. We can't show that, so we have to show the resonance. Remember, it's got brackets around it because it is charged and negative. And then we have 7 plus 35, which is 42 electrons. So iodine's the center. 10 away from 42 is 32. 6 times 5 is 32 extras. So we actually have 12 electrons around that. We call that a superreactant molecule. And with that, we're done. Hopefully that wasn't too bad. Take care. God bless.